So again, this is going to be negative and go from 0 to 3. Okay? So any questions on that one? All right. Last thing, just to kind of tie in what we did last class, you also have to be able to do limits. Oh, the range. I'm sorry. You're right. I forgot about the range. What do you think the range is going to be? Does it start, can I find the definite lowest point? No. So it's going to start from negative infinity. It stops. It doesn't go to 0. What's the highest point on the graph? It's right here. And what was the y value for that particular point? The y value of that point's what? Negative 1/3. Then it picks up again. It picks up at this point that's right above the x-axis. And that's going to be at 1/3. Am I including 1/3 or is it a boundary point? Boundary, so it's a parenthesis to infinity. It's not blurry here. Let me fix this. Let me fix that focusing.
So,
Yep.
the range, like, is that just standard? Do we even count it?
Is that what?
Or like 3, 5 for that point? Like, do we just point that and then we just run with it?
Yep. Yep. Yeah, the only thing it comes into account again is when we look at the domain, because even though 3 is not in the domain at this particular point, it is right here. So, yeah. All right, so the last thing for piecewise functions, again, is limits. So we did limits by direct substitution last night for homework. Remember, just a reminder, when we do limits from the right, we know we see that plus exponent. And when we see from the right, remember you're looking at x values that are slightly larger. Greater than. So we say limits from the right, you're looking at x values slightly larger that are greater than. When we talk about limits from the left, remember the limit notation, you see that negative exponent. So again, you're looking at x values that are slightly smaller. So you need to remember that slightly larger, slightly smaller idea when you're looking at a piecewise function in limits. And remember, for a two-sided limit to exist, you'll see no exponent with that particular x value. And for the two-sided limit to exist, remember the limit from the left has to be the same as the limit from the right. So let's take a look at this piecewise function and let's find these limits. So I want to find the limit as x is approaching 2. What does that plus sign mean? That plus sign means I'm coming from the what? From the left or right? Right, which means am I looking at x values larger or smaller? Larger. So again, looking at this piecewise function, where would I plug 2 into? If I want to be larger than 2, I'll plug it into which function? The second. So negative 2 plus 2 will give me 0. So again, the trick is figuring out what piece you're going to plug it into the piecewise function. When you see this negative exponent, what side am I coming from, the left or the right? The left. And am I going to be slightly larger or slightly smaller? Smaller. So where are my x values less than 2? The first piece or the second piece? The first. So it's going to be 3 minus 2 squared, which is going to give me a what? Negative 1. This is a what? A two-sided limit. So we have to know what's happening to the left of 2 has to be the same as what's happening to the right of 2. Are A and B the same numbers? No. So this one is a D and E. Does not exist.
Why?
Because what happens on the left of 2 has to be the same as what's happening on the right of 2. Had these two been the same numbers, then it would have just been the same number again. So let's take a look at 9a. The limit as x approaches negative 1, and what side am I coming from? I'm coming from the left. Am I larger or smaller? Does that mean left, smaller, or larger? That means smaller. So where am I going to plug negative 1 into, the first or the second function? Which one does it go into, first or second? First. So what is negative 1 squared plus 3? 4. So negative 1 from the right. Am I looking at x values larger or smaller? Larger. So where am I going to plug -1 into, the first or the second? Second. So 3 minus a -1 is 4. So tell me about C then. This is your two-sided limit. Is what's happening on the left the same as what's happening on the right? Yes. So this two-sided limit does exist, so this limit's simply going to be 4. You guys go ahead and try the next one. Those is our answers for those 6. Again, the trick is just figuring out, making sure left, right, left means smaller, less than, plus means greater than. If it's two-sided, you got to check to the left and to the right. Questions?
Why did you come up with letter D?
Which one?
Letter
Letter E?
D.
Oh, D. So the limit is x approaches 0. So what domain does 0 fit into? Does 0 fit into the first, second, or third? Yes, it is. So all I have to do is plug 0 in for x. So -3 times 0 plus 1, which is 1. I'm sorry? Where did D? D, yeah. Any other questions on those? So let's look at number 10. Does the limit exist at 0? So the questions really needs to know, does the two-sided limit exist? Does the limit, as x approaches 0 of f of x, does it exist? Well, in order for this to exist, what has to happen on the left and what has to happen on the right of 0? They have to be the what? Same. So what I have to do is I first have to find the limit as x approaches 0 from the right, and I need to see if that's equal to the limit as x approaches 0 from the left. So anytime you're asked to find a two-sided limit, you always have to know what's happening on the right and you have to know what's happening on the left. So first of all, when I'm coming from the right, I'm looking at x values what? Slightly larger or slightly smaller? Larger. So x values greater than 0 is the second part of my piecewise function. So when I plug 0 in for x, what is 3 times 0? 3 times 0 is just what? 0. So next I need to check and see what's happening with the limit as you're approaching 0 from the left, which means you're looking at x values slightly smaller. So where would I plug 0 into, the first equation or the second? First. So next I need to find the square root of 0. And what is the square root of 0? 0. So does 0 equal 0? Yes. So let me ask you the question again. Does the limit exist at x equals 0? Yes. Okay. The only reason you had to plug it in both places is because, again, I wanted to find the limit at the x value where the domain was cut off for both functions. So this is the limit from the left of 0. This is the limit to the right of 0. All right? So if you're trying to find the limit at where that domain gets cut off, you've got to plug it in both places for the two-sided limit. What about the limit as x approaches 1? No. Well, first of all, where does 1 fit into? What domain? Does 1 fit into the first equation or the second? Second. So all you have to do is plug 1 into the second equation. So 3 times 1 is just going to be equal to 3. You don't plug 1 into the first equation because, first of all, 1 is not less than 0. 1 does not fit in that domain. Like I mentioned, the only reason you had to plug 0 into both places was because 0 is where the domain restrictions were cut off. Because is 1 less than 0? No. Okay? All right. So everybody has, we're going to do some practice with our